We'll proceed in pseudo multivariate calculus. Pseudo multivariate calculus. This is what discussion that we set to proceed upon. Pseudo multivariate calculus. Very important and very astonishing. Very amazing. If I have a problem, then how I can come to a solution. Okay. In that sense, we talked about calculating volume of a sphere. Calculating volume of a sphere. If I have a sphere, then how we can calculate volume of the sphere? And what we saw with that, rather than calculating the volume of the sphere in a Cartesian coordinate system, we went with the de facto shape to calculate the volume. Then we went for calculating the volume of a cube, because cube is considered as the default shape for the Cartesian coordinate system. If there is a Cartesian coordinate system, x-axis, y-axis, and z-axis, what is the, if I say I have x-axis, okay, this is how we solve a problem. How we solve a problem? We start with the simplest thing. So if I have a Cartesian coordinate system, then how we can start with simplest thing? Consider I have x-axis. Then what is the default shape for the x-axis? Then it is a line. I have x-axis and y-axis. Then what is the default shape for this x-axis and y-axis? What is the default shape most favorable, most kind of homogeneous shape for the x-axis and y-axis? Then it is rectangle. What is the most favorable shape that is aligned with x-axis, y-axis, and z-axis? Then it is a cuboid or rectangle and height, rectanguloid or cuboid. That is the most favorable shape as far as Cartesian coordinate is concerned. I believe it's all right. Okay, if someone talks about theta and r, theta theta varies like this, and r from center it varies. Then what is the most default shape? Are you talking about theta r plane? Yes, I'm talking about theta r plane. If it is a theta r plane, then what is the most favorable shape in the theta r plane? Then it is circle. Circle is the most favorable plane in the theta r plane. Okay, if I have theta, r and phi, what about that? Okay, consider there is a radius that goes from 0 to r. There is an angle theta that sweeps to pi, and both are in 2D. Okay, there is another angle from vertical, it sweeps like this. Then it is called a spherical coordinate system. What is the most favorable shape of a spherical coordinate system? Then it is sphere. What is the most favorable shape for the polar coordinate system? Then it is a circle. What is the most favorable shape for the cylindrical coordinate system? Then it is cylinder. Most favorable shape for the Cartesian coordinate or rectangular coordinate system? Then it is cuboid. Okay, so we were trying to calculate the volume of a sphere through rectangular coordinate system, Cartesian coordinate system. In that sense, first we calculated the volume. First we calculated the volume of a cube, and we came to a kind of a pseudo code, pseudo algorithm. This is what we are trying. Okay, try to calculate the whatever the calculation we are trying for a simple case, and wherever there are variables, try to remodel the variable so that it will be more generic, in the sense that try to bring it in division and multiplication. Division will transform into differentiation, and multiplication would transform into integration. I believe it is again all right. Okay, now, how we calculated volume of a sphere? If there is a sphere, then how we calculate the volume of a sphere? How we calculate volume of a cube? Volume of a cube, volume of any entity. Volume of any entity is area vector dot product with the height vector. That is the volume. I believe it is all right. Again, if I have area vector, if I have area vector dot product with the height vector gives the volume. This much we have learned for sure. This much we have learned for the sure. Okay, if that is the case, then what is the area vector that I have to find out and then multiply it with the height. Okay, so for the cubical region, we took the top side as area vector and multiplied with the height. Then we got the volume. Or we took the area vector on xy plane and multiplied with the height. I mean area vector on the xy plane. That was xi cross product with the yj. Whatever vectors comes, dot product with the zk. That gives the volume. Or the top area vector dot product with the zk. Top area vector came as minus z by xi minus z by yj plus k. This is called area vector. Okay, into x and y. Whole is called area vector. Dot product, or in simple case someone can say x into y, z by x, I minus I minus x into y z by y j plus x into y k. This is called area vector. Dot product with the zk also gives the volume. Mind blowing, amazing. You have done something. This is what anyone would say. This is volume. I never thought that I can calculate volume just doing dot product with the area vector and the height vector. That's it. Okay. How I can calculate the volume of a sphere through the most homogeneous coordinate system, that is called spherical coordinate system. Okay, you talked about the cuboid is the most favorable shape for Cartesian coordinate system, right? What is the most favorable coordinate for the sphere? The most favorable coordinate for the sphere is a spherical coordinate system. Can we find volume of a sphere through a spherical coordinate system? Okay, so that is the concept that we are pursuing. How to find volume of a shape, how to find volume of a shape through the spherical coordinate system. What you are trying to find out? Okay, we are trying to find out volume of a sphere. This is a sphere, and volume of a sphere through the spherical coordinate system. If that is the case, then area vector into the height vector is the volume. Okay, hope. What is your area vector? Okay, now if I'm trying to find out volume of this is area vector. Make sense? This is area vector. And then what is your height vector? This proof is again not available in any of the book. If you're trying to find volume of something, try to get the area vector, multiply it with the height vector. That is the volume. Okay, do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code. Amazing, mind blowing. How to find volume of this sphere through the spherical coordinate system? What is the area vector? If I talk about this spherical coordinate system, this area, consider this is the area I am talking at a distance r from the center. Okay, that is the radius. What is the area of this? Area of this is the vertical arc multiplied by the horizontal arc. That is the area it is formed. What is the area on xy plane? That is x-axis cross product with the y-axis. xi cross yj is the area vector on xy plane. xy k vector. Okay. Similarly, If I try to find out area in a spherical coordinate system, then this side, this is one arc, and there is one vertical arc. If I do cross product of these two, then I get area vector. What is this arc and what is that arc? Okay, what is the vertical arc? Now this is the radius from center. If I draw this line, this is the radius, and this radius makes phi angle with the vertical. Radius phi angle with the vertical. Then this arc is in direction of phi, and it will be considered as r phi. R and phi angle. This is the radius from center. At this point, this radius is passing like this. Radius angle phi. If I talk about this arc, then it is r phi. R phi, phi unit vector. R into phi, phi unit vector. What about this arc? Because area has two sides. Area has two sides. I have to do cross product. So r phi, phi unit vector, that like I unit vector. R phi unit vector cross product with this vector. Now, if this is the radius, then sine phi, this cos phi, r cos phi talks about the vertical. R sine phi will fall on the xy plane or whatever on the horizontal plane. And then here, if I move theta, that is the horizontal arc. Radius only one side we are taking. So if I am talking about radius, then radius r phi, this is phi. So r sine phi will fall on the horizontal plane. R sine phi, and then r sine phi is the actual r on the horizontal plane. If this is the radius, at any point I am trying to calculate the area vector. Now, if I am trying to find the area vector at any point from center, this is the radius. R phi, this makes phi angle from the vertical. R phi is the phi arc. I am trying to find the horizontal arc now. R sine phi will fall on the horizontal plane. Now, on the horizontal plane arc, R sine phi is the radius. Now, R sine phi theta unit vector, that is the horizontal arc. So r phi unit vector cross product with r sine phi theta unit vector, or r sine phi theta unit vector cross product with r phi unit vector. That is area vector, knowingly, unknowingly. Okay, if that is the area vector, if that is the area vector, then this vector area vector is now theta unit vector cross product with the phi unit vector. Theta unit vector cross product with the phi unit vector. Then how much it will come? R R sine phi theta unit, R sine phi, R sine phi theta unit vector, R sine phi, R sine phi theta unit vector, or theta vector. Someone can say like that, or theta and theta unit vector, because R sine phi is the radius on the horizontal plane multiplied by the theta. It's like if I have x axis, then it is xi, it is yj. Xi cross yj is the area vector on xy plane. Similarly, r sine phi theta unit vector cross product r phi unit vector. This will come as r square sine phi theta into phi r unit vector, the cross product, because three vectors are perpendicular to each other in a spherical coordinate system. Theta vector, r vector, and phi vector. Okay. Can you prove that they are perpendicular to each other? I can prove it. Consider it is centered at the origin. From the origin, if I draw a radius, radius goes like this. It will pass this surface at 90 degree. Surface, it will pass as 90 degree. If it is passing the surface at 90 degree, then certainly radius is perpendicular to the surface. And then surface is made of vertical arc and horizontal arc. Vertical arc is perpendicular to the horizontal arc, and radius is perpendicular to the surface made by horizontal arc and vertical arc. means all three are perpendicular to the each other. R vector, phi vector, and theta vector, all three are perpendicular to the each other. That's why it is a coordinate system. Coordinate system, all three should be orthogonal to each other. Okay, what you got now? We got R. Now, what is the volume? Volume is area vector dot product with the height vector. Here, height is R vector because R vector is piercing this area at 90 degrees. If I am talking in Cartesian coordinate system volume, then area vector dot product with the height vector because height vector is exactly perpendicular to the area vector. So height vector is exactly perpendicular to the area vector. So xi cross yj, whatever vectors come, dot product with the zk, dot product with the zk. That is the net volume that we are calculating. Similarly, here we have r unit vector dot product because r is something if it is centered at the origin. From origin, if I draw a line like this, then it will pass through the surface in a perpendicular fashion. So this is perpendicular to the surface. Similarly, like xy plane, z axis is perpendicular. So r unit vector dot product with the r square dot product with the r square sine phi theta phi r unit vector because cross product of r sine phi theta theta unit vector cross r phi phi unit vector. So cross product of theta unit vector and phi unit vector result in r unit vector. Okay, understood. What is your formula that you tell me? Okay, formula is r unit vector dot product, r unit vector dot product, and then r square. Any moment, whatever r I had taken, r square, sine phi, theta, phi, and r unit vector. R unit vector will become it will become a 1. Dot product of two units, same unit vector become 1. Okay, r square sine phi. At any moment, I had taken r square sine phi. Okay, now we have r, that not I'm talking about that r square. These are theta and phi. Okay, now we are coming to a position where, because these are variable, in the sense these are talking about the axes. Okay, so we have r square sine phi, r theta phi. Okay, this is what it is. Okay, anyway, if that is the case, then looks like we have multiplication of two items. One item is r square sine phi and other is r theta phi altogether. If there is multiplication of two items and one item is dependent upon other item, it is candidate for the integration. So it becomes r square sine phi dr, d r theta and phi, that will convert into d of r theta phi, d of r theta phi. And now integration of this volume from one point v1 to v2. Now here r theta phi, r is going from 0 to a because this has radius of a. Okay, r is going from 0 to a. Theta is going from 0 to 2 pi. Phi is going from 0 to pi. R square sine phi dr d theta d phi. I believe it's all right. Okay, in that case, someone can proceed upon it. R square sine phi, let's settle down r square. It becomes r to the power 3 by 3. 0 to a to the power 3 by 3 that I can keep outside. Sine phi d phi, cos phi minus cos phi and 0 to pi. Pi is minus 1, 0 is 1. Minus gone, it will become 2. 2a to the power 3 by 3. D theta, integration will be theta. 2 to pi, 0 to 2 pi, 2 pi. 4 pi, a to the power 3 by 3, all 2 in one go one. Okay, this is called primitive way of calculating the volume. Okay, now understood. Can there would be something more similar to Cartesian coordinate, the way we were calculating what you were doing in Cartesian coordinate system? Anyone would ask what you were doing in Cartesian coordinate system. In Cartesian coordinate system, when we saw that if I was seeing, if I was calculating the area vector like this, an area vector came as area vector. In Cartesian coordinate system, area vector dot product with the height vector. Height vector is zk dot product with the area vector. Now area vector, if I talk about any point on this area, then I can cut in xz plane, I can cut in yz plane. xz plane, xz plane will give a shape like this, and yz plane will give shape like this. Okay, if you watch previous videos, if I cut this in xz plane, there will be a curve like this. If I cut in yz plane, there will be a curve like this. What is the vector representation of this curve and what is the vector representation of this curve? If I do cross product, I get the area vector. Vector representation of this curve in xz plane is xi plus zk. I believe we have talked in much detail about it. Okay, if I see any curve, I have to find the vector representation of this curve. Rather than this curve, I can find out the vector representation of any line. Rather than curve, I'll find vector representation of any line in xz plane, where this is considered. This point is here it is origin. This point is 0 comma 0 comma z, and this point is x comma 0 comma z. I am taking y as 0. Then this vector representation is xi plus zk. Then it will come as I plus z by x k into x. Okay, that is the vector representation of this line. I did x z by x because it is required. Z by x when we do, then only we can tackle curve, because curve has z by, if this curve is in xz plane, then if this is x axis and this is z axis, everywhere z by x is different. That's how it is different from a straight line vector in xz plane. In a straight line vector, z by x everywhere is constant. Many times we have talked like this. If I have a straight line and this is z axis, this is x axis, at any point if I divide z by x, it will come as a number. Any point if I divide z by x, it will come a number. That number will be same. But if I take a line like this or line like this in xz plane, every moment I divide line like this, every moment I divide z by x, z by x, z by x, every moment it will be different. So if I'm trying to find out the line vector of this curve, I'll try to find line vector of this straight line. That is, if this point is 0 comma 0 comma z and this point is x comma 0 comma z, or or 0 comma y comma z, any 0 comma y, I'm sorry, 0 comma y comma, okay, I'm really sorry about it. This line, if I'm trying to calculate the vector representation of this line in xz plane. Okay, in that sense, the vector representation this point and this point, there is change in z. Okay, there is change in x. There is no change in y because it is in yz plane. So this can be represented if this difference from this point and this point is x, and difference from this point to this point is z, then it can be represented as xi plus zk. Okay, now it can be written as I plus z by xk whole multiplied by z. Now this cross product with another one in yz plane, that is yj plus zk, yj plus zk, j plus z by yk into y. Cross product of these two gives the area vector. So when we are talking about area vector, when we are talking about area vector, then I cut it in xz plane, I cut it in yz plane. Xz plane resolves in this curve, yz plane resolves in this curve. This curve, I have to find the area, the line vector. This curve, I have to find the line vector. If I do cross product of these two, I get the area vector. This curve line vector I got as I plus z by x j z by x k whole into x. Now z is dependent upon x, it becomes dz by dx. So I plus dz by dxk into x. Now I plus dz by dxk, and other side it becomes j plus dz by dyk into y. What is I plus dz by dxk? Anyone would say it is dp by dx. It is dp by dx. What is p? P is any point on the surface, that is x comma y comma z. I take any point on the surface as x comma y comma z from center. If I draw a vector, the position vector is xi plus yj plus zk. dp by dx is I plus dz by dxk. Same thing. So area vector what we calculated is I plus dz by dxk out bracket x cross product with j plus dz by dyk outside into y. It is same as dp by dx cross dp by dy and then multiplied by x into y. Same thing. So dp by dx cross dp by dy, dp by dx cross dp by dy, it will result into a vector. Now whatever vector it is, it will be in form of x and y into xy. Means this form is dependent upon xy. This multiplication will turn into integral calculus. Okay, that we will see. Whatever it is. Now if I want area vector, then it is dp by dx cross dp by dy x into y. Okay, this is another way. Similarly, if I talk about here, then what then area vector will be? Now there the independent component was x and y. Here independent component for the surface is theta and phi. dp by d theta cross dp by d phi into theta into phi is the area vector. Makes sense? It looks like more scientific. Area vector is dp by d theta cross dp by d phi, theta into phi. What is p? Position vector. The position vector, if we talk, then it is 3 cut dp by d theta. Okay, now how if I talk about the position vector, any point here, okay, any point is made from vertical arc, horizontal arc and radius. That is the point here. Then the if I talk in the vector form, then it is r sine phi, it is r sine phi theta vector, or theta into theta unit vector, r sine phi theta into theta unit vector. This is what we have demonstrated, plus r unit vector or r vector. So r sine phi theta vector plus r vector plus r phi vector. That is the position vector of that point. Make sense? In spherical coordinate system, pure spherical coordinate system. In ijk, then it will come as r sine phi cos theta I plus r sine phi sin theta j plus r cos phi k. This is a spherical and Cartesian coordinate hybrid. If I talk about pure spherical coordinate system, then it is r sine phi theta vector plus plus r vector plus r phi vector, or r sine phi theta unit vector plus r unit vector plus r phi unit vector, whatever comes in. dp by d theta cross dp by d phi will give the area vector into theta into phi whole multiplied by r vector, or with the dot product with the r vector. If this is area vector and radius is passing from center, radius is passing like this, I have to multiply with the height vector to get the volume. R vector dot product with the full in braces. What is full? dp by d theta cross dp by d phi into theta into phi. dp by d theta, what is p here? That is r sine phi theta vector plus r vector plus r phi vector by d theta cross d of r sine phi theta vector plus r vector plus r phi vector by d phi. If I do by d theta, first will become r sine phi theta unit vector. R sine phi theta unit vector. All are gone. All are gone. Cross product. Now, if I differentiate with the phi, then it will become r cos phi theta vector. Theta vector. R cos phi theta vector. R is gone. And next is r. Simple r phi unit vector. Now we have altogether cross product of two vectors. One is r sine phi theta unit vector. Cross product with the r cos phi theta vector, not theta unit vector, theta vector plus r phi unit vector. Theta unit vector and theta vector, whatever cross product is zero. Only theta unit vector and phi unit vector cross product will happen and it will result in r unit vector. So it will become r square sine phi r unit vector. Okay, d r unit vector theta into phi. Now, if that is the case, then we can proceed multiplying it by r vector. Then it will become r square sine phi r into theta into phi and then gone. Because r vector will become r and r unit vector. Dot product will become 1. Same thing what we did in the previous section. But we came through differentiation of position vector. R square sine phi dr d of r theta phi. Volume 1. R theta phi is the volume. D of r theta phi or r theta phi is the volume. And this side it is like a density function r square sine phi. If it is like that, then it is multiplication of dependent and independent component. Independent component is a volume r theta into phi. Dependent component is a density function, that is r square sine phi. Volume one position to another position, it will give the net volume r square sine phi d of r theta phi. Volume one position to another position. If that is the case, then someone can go ahead and break the integration into three parts. R is 0 to a, phi is 0 to pi, because phi will proceed vertical pi to here, and theta will proceed complete to pi, and theta is 0 to 2 pi, phi is 0 to pi, and r is 0 to a. Same it will become as 4 pi a to the power 3 by 3. Okay, 4 by 3 pi a to the power 3 is the volume of a sphere in a spherical coordinate system. Mind blowing. So area vector is dp by dx cross dp by dy into x into y. This is area vector. Or dp by d theta cross dp by dr, dp by d theta cross dp by d phi, theta into phi. This is area vector. Okay, someone can proceed in the area vector in cylindrical coordinate system. dp by d theta cross dp by dz, theta into z, because that is the surface where z and theta are variable, not the r. dp by d theta cross dp. Now, p position vector someone has to find in cylindrical coordinate system, not I, j, k. That will be in theta, z and r. Then someone can calculate volume of a cylinder, volume of a cone, surface area of a cone, surface area of a cylinder, surface area of a sphere. When you have area vector, you can calculate surface area of the sphere also rather than calculating the volume. Mind blowing, amazing. Do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.